Sure. Okay, so before we start with this webinar, I just quickly wanted to introduce myself and our instructor. My name is Anukriti Jain, and I work in a capacity of account manager, and I have been associated with Cognitia from past 3 years. We do have an instructor, Vishal, with us. Vishal comes with an experience of 20 plus years in his particular domain, and he has been associated with Cognitia from past 7, 8 years. Vishal, would that be a possibility if you can give a quick intro about yourself, and then you can start with the webinar topic? Vishal, in case if you're speaking, you're on mute.
Always a problem when you have an online training.
No worries.
Guys, good evening. I hope everyone is able to hear me.
Yeah.
Getting an echo right now. I'm not. How about now? I hope everyone is able to hear me, right? Guys? Right. I think I have fixed my audio issue. Yes. So hi, good evening, everyone. Middle of the week. I hope everyone is fine. My name is Vishal Seni, and as Anukriti has told, I've been working with Cognitia from almost 7 years now. I've been associated with Cognitia. Basically comes from a system administration domain. So I started my career somewhere around in 2005, 2006, working as a system engineer or a desktop engineer. That used to be a profile at that particular time, and I got my very first Red Hat certification in 2008. And from then onwards, I've been actively working into Red Hat domain. So at one point of my career, I was working as an SME on Linux platform, working as a technical trainer and consultant, delivering and providing support for customers on different Red Hat products, more specifically Ansible, OpenStack, and OpenShift. And yes, from past 6, 7 years, I've been actively working on uh, the tools and technologies associated into DevOps, ecosystem. We talk about running and executing a CI/CD pipelines using Jenkins, GitHub Actions, or the GitLab pipelines, or specifically working on to containerization technologies like Kubernetes, the RKEs, or OpenShift. Yeah, that's about me. Now we have a very limited time to cover up a lot of topic. Frankly speaking, uh, understanding a container ecosystem and working on it, it's fun. Obviously, there are a lot of things which you can learn, and I'm going to get started with it without any further delay. Just going to share up my screen. I'm going to use my iPad to share the screen. Obviously, it gives me more flexibility with respect to explaining certain topics and giving an overview while writing it on the screen. So that's the methodology which I'm going to use for conducting this particular webinar. Right. Obviously, after I complete this webinar topics, we will have a quick Q&A scenarios as well, where you guys can put in your questions, and I'll see if in case I can answer those things to you. Right. We have a lot of participants in the call, right? I can see around 224 people who are actually in the call. Thank you very much for joining in again. And let me share up my screen. I'm just going to switch off my camera right now, and I'm going to share up my screen. Just give me a sec. All right. I hope everyone is able to see my screen, right, guys? So yes, this webinar is all about understanding Docker and Kubernetes, right? Frankly speaking, when I first heard about containerization and when I started working on Dockers and stuff, I was a bit confused. This is 2013, 14 I'm talking about. I used to work upon virtualization technologies, and I was aware of OpenStack, AWS, and stuff like that. So it was kind of a new topic for me to understand what exactly containerization is. And, I have a curiosity understanding, like trying to understand what exactly that particular thing is. And that's the agenda for this session. We're going to understand what exactly container is, how it fits it into the picture, right? The current scenarios, the current ecosystem of software delivery, where exactly containerization fits in, what exactly Docker is, and what's the difference between Docker and container. That's one major question which comes into the mind all the times. And then obviously we'll talk about Kubernetes. I'll try to cover up some of the topics via doing a small hands-on practical as well for you guys, just to demonstrate it to you that how easy it is to deploy an application or build an application on a container ecosystem, right? So that's what we're going to focus upon. This is what the overview of this webinar would be, as you can see, we will be understanding what exactly containerization in general is, right? We'll go back to the basics, try to understand where exactly container comes from, what were the solutions which were there for us prior to the containerizations, what their advantages were, what were their disadvantages and stuff like that, right? So the first thing is all theory. I will try to understand uh, where containerization fits into. All right. And then obviously what Docker does for us. We'll talk about some basic fundamental concepts, operations, which we can perform using Dockers. Then we'll talk about why K8. K8 is basically Kubernetes. We'll talk about a simple Kubernetes architecture, and then we'll try to see how to deploy simple applications on Kubernetes platform and access it from the outside. Right. We'll try to do this thing demo, right? And we'll see how exactly it can be eventually possible for us, right? So this is about me, right? One point of my career, I was an RSCA, which is Red Hat Certified Architect, uh, level 8. I'm also an AWS certified professional, Azure certified administrator. I've been working into Kubernetes from almost 6 years. So I have the CKA, CKS, CKD, all these three certifications as well. All right. So let's get started with the topic of what exactly containers are, right? So in this particular topic, we're going to talk about the traditional meaning of application deployment. The major question which comes into the picture is the difference between containers and virtual machines. And then we'll talk about the history of containers as well in general, like how exactly container have evolved, right? So that's the topic which we are going to discuss in this particular, right? In this particular module. So whenever I basically starts talking about containerization, taking any technical delivery or going on a customer site and explaining them about the functionalities of containerizations, right? I always talks about the things which were there traditionally before containerization came into the. So eventually we are talking about software, guys. Okay, software equal to application, whatever you want to call, right? So you're looking out for, making sure that we need to host the application. Now, the application could be a very simple program of just taking an input and printing an output, or maybe a much more complex program with multiple functionalities and additional services integrated in. It doesn't matter. We are just talking about from the software point of view that eventually we need a software to up and run. All right. And for running those softwares, obviously, we would require what you call a system, computer, server, hardware, whatever you want to call it. It's all the same, right? So at the end of the day, for running an application, because it's a software, it's a program, it's a code, we basically would need a system, a hardware with CPU, RAMs, a computing power, the storages power, and stuff like that, right? So we are going to discuss about that particular thing in here, right? So that system, right? That system which is going to be used for hosting my application, how that system have evolved over a period of time. And that is the reason why the title of this particular slide is P to V to C, which is physical to virtual to containerizations. All right, guys. So we're going to talk about all these three things in detail. What was the solution these technologies was offering to us? What was the disadvantage? So initial times, like earlier, I'm talking about 90s or 2000s, right? We used to have what you call is the physical system. So for each and every individual application, we used to have individual servers with individual configurations. And on top of it, we used to run our applications. As you can see over here, this is just to give you a small demonstration. Like we have three machines right now, machine number one, machine number two, machine number three. Right now, all these three machines, as you can see, have some hardware configurations as well, some CPUs and the RAMs. And then on top of it, we are running some application. This one is running a web server. This one is running a mail server. This one is running a file server. You can have any sort of application. It does not matter. We eventually have three applications running on top of it. All right. So what you're able to derive from this small presentation, like the first thing which comes into the mind is all these machines are currently underutilized. All right. And this was one major concern which we used to face when We don't have any other solutions apart from running the applications on the standalone server. So like one application running on one standalone server, right? We basically, before deploying the application, we did what you call the capacity plannings and stuff like that. And later on, we realized the expected load was never there. So eventually the machines were underutilized. Now this is physical system. Cool. The problem, we got the problem that machine are underutilized. Obviously, there is no cost effectiveness and stuff like that. All those things are secondary problems, which we always have to tackle. But the major concern which we used to face was underutilization. Now I have a very simple theory behind this, right? The machine is underutilized. We got it. What we are talking about in here is, let's suppose, take an example. If I create a single machine, let's suppose, take an example. If I have a single machine to work with, okay, one simple machine with some hardware configuration, right? The CPUs and the RAMs will be focusing upon computing. Storage is always expendable. That's not an issue. On top of it, we are running an operating system. Let's say in the previous times, you're talking about Windows 2000, so 2003 servers, or prior to that, Windows 98 and 2000 also, right? You're talking about those operating systems. On this operating system, I'm running my application, app1, any application, app1, which we are running. And what we are able to see is machine is hardly utilized. You're saying 10% of the machine is basically being utilized, right? So eventually, operating system, right, has a capacity of running multi-process, right? Like they have a functionality of doing multi-processing, multitasking. Like the earlier versions also, Windows XP, we are able to run browsers, we are able to run the VLC player, Real Media Player, and stuff like that, right? Microsoft Office, we can open up multiple applications. So if the operating system has this functionality, eventually we can actually run another application on top of the same OS. This was one possibility we had, right? Like if you go back to this particular problem, machine being underutilized, we do have the functionality to deploy more than one application, right? So I can have one, more than one application. So I'll say multi-application deployment on a single server. The problem with this would be with respect to a term known as isolation. So obviously we had this possible solution. We can have multi-applications, but the problem with this would be that you have isolation issues, right? There are two major type of isolations which we have to talk about: the hardware and the software isolation. Okay. You're running more than one application. Both these applications required some hardware, right? They started using the hardware. Eventually, what will happen? There could be a scenario where there is an unexpected load coming on both an applications, and now you don't have any free hardware to allocate for any of these applications, and you will face an issue of application failure, maybe out of memory errors or stuff like that. So there is always a hardware issue, and then obviously there would be a software isolations if you're running a multi-app setup. There could be a scenario that both these applications currently are running with the same OS, same application binaries, libraries, stuff like that, right? Later on, there could be a scenario where you have to upgrade one of the applications, and the latest version of that application would require you to change one binary. So you can face those issues. And that was the issue, that was the concern, which leads us to looking into different solutions rather than running more than one application on a single server. And we come across, obviously, this is what we are talking about, hardware wastage and costings in terms of physical server. So we come across with the concept of virtualization. All right. This was the boom, talking about a solution which, kind of the best alternative you can think of at that particular time. So people started working on virtualization. This is V for us. So from P, we moved toward V. So physical server, we were facing the hardware isolations. We come across with virtualization. Now, if I go by the generic definition of virtualization, you're talking about having one hardware running more than one operating system simultaneously with multiple operating systems with multiple application stack. And to perform the virtualization, we basically would have what you call hypervisor, right? So guys, again, I'm not going in detail with this particular thing, but I'm going to get you through with some basic explanations or basic terminologies which everyone can understand, right? So virtualization is basically a technology of running more than one operating systems on a single hardware. How do you achieve it? you can achieve it with a software known as hypervisor. There are also types of hypervisors, type 1, type 2s. I'm going to focus upon generic hypervisor concept. So rather than running a setup like this, we come across with what you call the virtualization concept. Okay, so you take one machine. Let's suppose this machine got on hardware. Okay, and I'm focusing upon type 2 right now because we have to come across with the containerizations also on top of it. So let's suppose on this, you're running a base OS, right? This is known as base operating system, parent operating system. On top of which, you will install a hypervisor. So hypervisor is just a software. Like some of you might have heard about Oracle VirtualBox or VMware workstations. These are type 2 hypervisors we have. The VMware ESXi or the Citrix Zen or the KVM's technologies, all those are type 1 hypervisor where you don't have to install base OS. So I'm going to focus upon base OS right now. So base OS, you install hypervisor. This hypervisor allows us to create what you call VMs, virtual machines, VM1, VM2. On these VMs, you can have virtual hardware allocated. On top of virtual hardware, you can install your own operating system. And then on top of it, you can run your own application stack, app 1 and app 2. So at one shot, you are able to resolve two problems. You're able to resolve what you call hardware wastage. All right, coming back to the topic. Sorry for this. Yeah, screen is shared. You guys are able to hear me. Thank you very much for the confirmation. So virtualization at that particular time was able to offer us salvation, I would say, right? You are able to get hardware wastage problem, rectified, because what we are able to achieve is we are able to run more than one system or more than one operating system with an application on top of it, running in a completely isolated manner, right? So the hardware wastage as well as the isolation, both things were able to, were able to be rectified with the introduction of virtualization. Now that you have two applications running on different operating systems, you can upgrade these applications. The binaries can update it. It will never affect the first one. Same way, both these applications are running on their complete isolated hardware. So if there is a requirement for additional hardware for a single application, again, it's not going to impact the second one. So this was one of the best thing we were able to get via virtualization. We are able to get what you call a hardware wastage problem rectified, as well as the application isolation problem rectified. This is the next big thing after physical servers. So I remember, my first organization for which I was working on, they were moving, there were transitions from physical servers to virtual machines. And I was like, yeah, this is the best solution you can get. Right now, the concept of virtualization is not new, guys. Right, 1996, I would say 1996, 97 is when VMware was founded. By the year 2000, they made a patent on virtualizations, right? And eventually, everyone at that particular time was like in awe with respect to virtualization solutions. You are able to get more than one operating system running simultaneously. You are able to get the cost effectiveness out of the system, and eventually, the isolation factor is also there. Cool. But there was some community, there was some people who were not fully satisfied, or I would say was not fully on board with respect to virtualization at that time, right? If you ask me personally, the first time I heard about containerization was in 2014. Okay, and I'm pretty much sure that majority of us who are sitting on this call right now, they would be on the same page, right? They heard about containerizations somewhere in 2013 and 14. So for me also, containerization was that thing. What if I tell you containerization is a way old thing? So let's go back and understand a bit of a history. So containerization, we'll talk about this in a while, but let's give you a basic concept of containerization definition, right? So you're talking about process isolation. Okay. If you go by the definitions or the internet solutions or blogs and stuff like that, Majority of the time, people say virtualization is more about hardware isolations, doing isolation from the hardware level. So what we did in virtualization, rather than working on the OS level, if you look at this particular diagram right now, which I have created, right, we are able to see that we have created two VMs altogether, right? That's what we did. We basically created two different VMs, which obviously, so you can see this is first VM, this is second VM, and we did the isolations from the hardware level itself. We gave them different hardware, to hardware, and on top of it, they are running their operating system. So virtualization is more into hardware isolations, I would say, right? When you talk about containerization, people will say containerization is more with respect to software isolation. Okay, containerization is more with respect to software isolations. So let me give you the brief idea about containerizations in that regard. All right. People I'm talking about are mainly from the Linux community, right? Containerization in Windows came somewhere in 2018, 2017. Right? Windows almost took what you call 15, 16 years to migrate from 32-bit to 64-bit. So containerization in Windows was not a thing in early 2000s, or from the 2010s or 2013, 14 also. So the people I'm talking about, they were basically from what you call the Linux community. People who are working on FOSS, right? People who are who belongs to the open source community. So they specifically focused upon process isolation, guys. I'm going to give you 1 second of definition of what exactly process is. You basically have an application, okay, application or a program, which is typically a code, okay, code stored on your hard drive. Let's say on your Windows drive, you all are aware of C drive, D drives and all. So we have an application program code, which is written and being stored on my hard drive in a different folders. So when that application is not running, your code is totally isolated from other application codes. Usually when you run the application, that code gets executed. So it goes to the RAM and then, high level stuff. Then it goes to the CPU. That's where the computing happens. And then you get the output or you get the error depending upon the input and stuff like that. So this runtime execution of your program is technically known as process. Okay, technically known as process. So people of this Linux community, they focused upon what you call is the process isolation. Okay, this is what I'm talking about. This is what their thinking was. They were not aware, like they were not focused specifically upon doing an hardware isolations, right? Hardware isolations was already done by virtualization. VMware has already performed. Let me give you the issue with VMware. Consider an example. You have two applications running on a Linux-based OS or a Windows-based OS for that matter. Let's suppose app1, which requires a Windows 10 to run. And you also have another application, app2, which also requires Windows 10. Okay, now to run it on virtualization, you created two VMs for this solution. Now, obviously, the only difference between these app1 and app2 is with respect to one single binary. Maybe just to give you the idea, one required Java 8, one required Java 11. And just to run Java 8 and Java 11 separately, you're running two copies of Windows separately. Okay, and that was the problem. People were not aware of this problem at that particular time because number of applications were not that huge and stuff like that. But nowadays, if you talk about multiple applications which needs to run on Windows 10 with small, conflictions or with respect to a single binary or library, you may be running more than one Windows operating system in a duplicate manner, wasting the hardware, right? And that was the concern which these guys, predicted in 2000s or 1996 or 7, I would say, right? So the Linux community people, they were not focused upon this. This was already achieved by VMware. They were specifically focused upon process isolation. And this became what you call the principle
behind containerization. So containerization, if you have to define containerization to anyone, that what exactly containerization is, I would say it's more specifically with respect to the process isolations. Running multiple processes inside a single operating system with complete isolation is what containerization is. Okay, this is what containerization is. That's basically what you can say in terms of, like, if you have to define it to someone, running more than one process in a completely isolated manner with a single machine is the idea behind containerization. Okay, and this is not new. This whole idea of containerization is not new, right? So if you go back to the timeline of this, there are a lot of things which was happening earlier. So the Linux community, I would say, they started working on B server. So BSDs, like, they are way back. So jail technologies, this is more specifically to the people who are aware of Linux platform. These terminologies would be easier for them to understand. People who are not from the Linux background, they would say, like, what exactly is happening? Guys, this was Linux people doing the work on containerization, working on focusing upon what you call the process isolation in 2000, I'm talking about, right? So the idea of containerization, the term containerization was not coined at particular time, right? But the idea of doing process isolation is way older than we think. So in the year 2000, the open source communities, the BSDs, basically were working upon the jail technology. We technically call it as chroot. Okay, so chroot is an environment within the Linux to run process in an isolated manner. The very first thing, right, the technology behind containerization, that something, the process isolation factor, the Linux community introduced what you call a project known as vServer, right? So vServer was the first attempt at running what you call a process in a complete set, in a complete isolations inside a single server. So if we are planning to run one application with one process, this process is supposed to run in a completely isolated manner. And that was the idea behind vServers. So process isolation is not new. It was there in the market from way old, right? Solaris, they basically introduced the concepts of zones. Uh, Google, they introduced the concept of cgroup. All these things was happening on the Linux kernel level. So Linux was, will, and always be a kernel. So within the Linux kernel, they were adding what you call the functionalities. Okay, so from 2000, so because it's an open source technology, no one has what you call a proprietary license for it. It was all open source. All peoples, all organizations, all companies, all developers, they were integrating their work together to achieve the best possible solution for it, right? So they were making their solutions and, you know, introducing it or putting it inside the Linux kernel, right? So within the Linux kernel, if I may explain it to you, within the Linux kernel, there were a lot of solutions which you got added. So I'll give you the basic idea on this. Within the Linux kernel, there are four specific, I would say, functionalities which were added from 2000 to 2008. Okay, and there are a lot of other, like, there are a lot of organizations which integrate these solutions. So the first is cgroup. Cgroups is a method for what you call the resource utilization. So if, let's suppose, one process is running, how much CPUs or how much RAM that process is going to consume is something which you can control via the cgroup. SELinux. So a process, how much CPU RAM is controlled by cgroups. What all files, right? So take an example, when a process is going to run, it may have to access some files from C drive or D drive, or like in terms of Linux, we'll say a process needs to access a file from /etc or /var or /lib or whatever, right? So if one process is running, what all files can it access from your file system is something which is controlled by SNX, right? You're talking about SecComs. SecCom is something which was basically introduced as container Sira and stuff like that, right? You're talking about what you call when you're running a process, what all system calls it can make. System calls is more like uh, interacting with the hardwares, requesting to the hardwares with respect to which hardware to use, what request to be sent to the hardware and stuff like that. So SecCom was another technology which was basically introduced to do the isolations for process. And then you come across with another terms known as namespace. Okay, namespace, which is basically again, isolations with respect to different stuff for a particular process. Like take an example, you're talking about what all network interface a process can execute or work upon, what all processes, you talk about IPCs, inter-process communications, you talk about the mount namespaces, the user namespaces, and stuff like that. So a particular process which is running, there are different methods to provide isolations to that particular process via the namespace. So all these things, all these concepts was actually introduced in the Linux kernel to provide isolation for a process, right? Isolation to the process is achieving what you call containers. So all these technologies were added into Linux kernel from 2000 till 2008. So if I revamp this diagram for you for a while now, in terms of containerization, we were focused upon having one machine with hardware, with an operating system. So this operating system should have what you call the Linux kernel at that time. The Linux kernel base OS is Reddit OS, SUSE, Ubuntu, Fedora, and stuff like that. And then using the functionalities of Linux kernel, we were able to run the applications in a completely isolated manner on the same OS in the forms of containers. This is what your Linux community was able to achieve from 2000 to 2008. All right. So all these, I would say modules, functionalities, modules, that's what you're talking about, functionalities, features which got added into it. Okay. In the year 2008, more specifically, we got an introduction of LXC, Linux containers. So at that time in 2008, Linux kernel got the functionality to run containers in a completely isolated manner, run the processes in the completely isolated manners. So LXC was the first full-fledged container solution offered on the Linux-based OS, right? And this is 2008 I'm talking about. So when we now heard about containerization, Linux-based operating systems were already have the functionalities to run processes in the isolated manner. This is history. We haven't discussed anything about Docker as of now. Okay. Now going back to the same stuff. So containerization, good solution. We are able to do this work. Obviously, they are very portable, very small. They have extremely small footprints, like 100, 200 MB is what you call is the size of a container. More specifically, you can run more than one container on a single system. It's pretty easy to spin up the applications. By the flick of your hand, you are able to actually run the applications altogether, right? So all these things are what you call the advantages of containers altogether. I'm going to take 5 minutes for question Q&A. I know there are there could be a lot of questions with respect to it. So I'm going to take 5 minutes if in case anyone has any questions related to whatever we have discussed. Mind you, we are still we are going by the timeline. So we are still in 2008. We are not in 2023. We are 24. We are still on 2008. So as of now, the only things to run the container which was available for us was LXC, using the traditional solutions based upon Linux-based platform. All good, right? Any questions? You are free to write it on the chat. I would say no. There are a lot of other. So LXC is again a full-fledged solution running your containers altogether. So now the problem with LXC was like it came before its time, I would say, right? Like in simple terms, something which was so in 2008, right? Like there were hardly n number of people throughout the world who were aware of Linux at that particular time, right? So there was not a huge audience of Linux operating system at that particular time. Windows was still an operating system to be used on the server. So LXC was not that easy for people who are not aware of Linux. So now there are a lot of other alternatives which are available for LXC. So it's not being used. Anyhow, it's something which runs inside the backend altogether. Okay. Use cases of SC Linux, guys, it's pretty important. Like if I'm running a single process inside my system, right? And I don't want, so I'll give you the basic understanding of this with respect to a Windows machine. So let's suppose within the Windows machines, you have C drive, D drive, E drive, and F drive, right? SC Linux doesn't run on Windows, but just to give you the idea, I'm running a process. I don't want my process to access C drive. We can control it via SC Linux. I only want to give the access for that particular process to access a folder within the D drive. That is something which I can control via the SC Linux. So SC Linux, what all files within a file system your process can access is what SC Linux can give it to you. TechCom is another functionality which gives the process to control system calls. So system call is in the Linux term is basically a program which interacts between a shell and a kernel. So eventually, every time a command needs to interact with the hardware, it basically interacts it via a system call. So it's again a predefined computer programs, software programs runs within the operating system to give access for a particular process to communicate with a hardware. How to communicate? So like take an example, if you are interacting with the hard drive, right? You are not going to send print request to a hard drive. Doesn't make any sense. So which request to make to which particular hardware is what seccom controls. Whether LXC is multiple shell on a single Linux kernel. No, LXC is just a program. LXC is a simple program which uses the functionality of Linux kernel to run containers on top of a Linux-based operating system. Hypervisor is a very simple program. I'll let you know. Hypervisor is a software program which allows us to run more than one operating system on a single hardware. So take an example, if I'm running one operating system on single hardware, I do not have the functionality to run another OS at the same time. Hypervisor is that program which gives us that functionality. So you have different types of hypervisor. Like when containerization was evolving, it was only running on a Linux-based operating system. Nowadays, containerization is matured enough to run on Windows as well. But in previous, so if you talk about from 2000, 2008 and stuff like that, Windows was nowhere in the picture with respect to application isolations on containers. Is it possible to install containers in Mac? If can show the interface. Mac in the sense, container is the end result. At the end of the day, container is the end result. You need what you call a container engine to run containers. Okay, and that's what we are going to discuss right now. Which LXC alternatives are being used? That is also something which we are going to discuss. Okay, that's what the next topic is. That's what Docker is all about. So we are in 2008 era. LXC is one of the first full-fledged solutions based upon Linux platform to run containers. Obviously, 2008 Linux was not popular in general. Okay, I'm talking facts right now. So in 2008, Linux was not popular because obviously everything on Linux, to work upon Linux, we need to use CLI. So we used to run a lot of different commands to run. We will be getting it. That's what I'm going to show it to you. We will be seeing the demo of containerization, not to worry about it. Yes, obviously, if in case you want to run virtualization, you will be needing more than you'll need to install a hypervisor, and then on top of it, you install operating systems. Again, that's another option. I'll be showing you to the concept of Docker and running some containers on top. Logistic parts, let's Ria or Anukriti handle that thing. I think you should be getting the recording for it. It will be available for all of you. Coming back to the topic, guys, we still have a lot of topics to discuss. Linux in 2008 was not popular because it was CLI based. So even though the concept of process isolation was already there, it was not popular. Okay, and the reason why it was not popular is because as a general user, like if you ask me, 2008, I was working on Windows. For me also, I was like, why do I have to go into that CLI mode to learn anything, right? We have Windows, everything is on the click. You have a good UI to work with, interface to work with. Why to go into CLI? So a general public in 2008 was not expertise enough to work upon Linux. And frankly speaking, because of that, LXC was not popular. Okay. Now fast forwarding to 2013. From 2008 till 2013, there were a lot of things which happens in the market. But frankly speaking, containerization, does not become popular at that time. Reason being, it became it like I would say the audience was there. People were listening to the gossips and stuff like that. Yes, there are options to run process isolations, but frankly speaking, no one was taking I would say leap or jump into the boat of containerization at that time, because frankly speaking, from 2008 till 2013, people who are not aware of Linux, they has to learn Linux first, and then on top of it, they have to learn the concept of LXCs. Okay, LXC was, I would say, more native approach of doing containerization. In 2013, Docker came into the market. Docker organization, Docker.inc came into the market, and they basically created their software, which is known as Docker. And what they told people, like, boss, if take an example, you are working on, I would say, a Linux operating system. If you are aware of Linux, so you will have this setup right now. OS with the Linux kernel. The Linux kernel would have all those functionalities of C groups, SCLinux, namespaces, and stuff like that. Now, Docker gave a very simple functionality to an end user. Docker says, boss, if you're an end user, there is no need for you to understand the concept of C groups or SCLinux or LXCs in general. You don't have to worry about this. What you can do is, on your Linux-based operating system, you install my software, which is Docker. Okay. When you install Docker on your system, you will get two things. You will get a very simple Docker CLI, and you will get a Docker server software. When you install Docker on a simple Linux machine, you will have a CLI and you will have a server. User can use the very simple Docker CLI to interact with containers, right? So Docker gave a very simple functionality to the end user, saying, boss, you don't have to worry about SCLinux. You don't worry about C groups, SCLinux, stuff like that. Don't worry about it. I'm going to give you a very simple interface. You just have to interact with that interface. Okay. The only thing which you need to do is you just need to interact with that interface to work, right? To operate. You just send a simple instruction. That simple instruction will be forwarded to the Docker server. The Docker server will talk to the LXCs or the Linux kernels in the background to run the final containers for you. That's what Docker did in 2013, guys. And that is the reason why Docker became so popular. And because of Docker becoming so popular, containerization became popular. Prior to Docker, containerization was there, the process isolation was there, but frankly speaking, it was not that easy. Okay, Docker made it easy. And that's where the concept of container engine. So Docker is a container engine. Okay, Docker is a container engine, or more specifically, if you have to go back, container runtime. That's what people call it. So Docker is a container runtime. it allows users to run containers on a Linux platform without have to worry about the underlying infrastructure. Let me give you the basic idea. If you want to drive a car, right, you don't have to worry about understanding what is under the hood. The only thing which you have to worry about is clutch, gear, brake, and race. That's it, acceleration. Docker provided that to the end user. Docker says, I'll give you a very simplified CLI. CLI, a very simple CLI to work with, right? You can work upon that CLI. That CLI will take your instructions and will interact with the Linux kernel, the LXCs, to perform the task, whatever task. So this is LXC for us, Linux containers. We have already discussed C groups and stuff like that, right? So this is what Docker did in 2013. And that's when containerization became general. Containerization became popular. Because Docker CLI, frankly speaking, was very simple CLI to work with. CLI stands for command line interface. Simple. Okay. So you got Docker to work with, and Docker simply gives you that functionality. So Docker is a container engine which allows us to run, manage containers all together on a single machine. Okay, that's what basically Docker did. Docker allows us to run containers. So Docker, as you can see, it's a set of platform as a service, PaaS in simple terms, which allows us to provide containers. As you can see, Docker is a tool that is used to automate the deployment of applications in a lightweight container so that application can run efficiently on a different environment in complete isolation. It's not CXC, it's LXC. LXC is Linux containers. We have already discussed. Okay, the explanation is not yet over, Sandeep. Frankly speaking, there are a lot of things which we can. So we are still in 2013, right? We haven't reached to 2024. If you go back to the documentations right now, you will see there are a lot of other better alternatives which are available in the market apart from Docker, and organizations are currently using them. But then again, we will be focusing upon Docker right now. So Docker in 2013, when it came into the market, it gives users a very simple CLI, command line interface to interact and create the containers. And that's when containerization became popular. So this is what a Docker architecture is, that you install. I can go back into PaaS. PaaS is platform as a service, where as a user, you will have access to deploy your application. Just to give you the basic idea, let's suppose you're a software developer and you want to deploy your application, right? You will be writing the code. Okay, you will be writing the code. So code is on you. But to deploy the code, your operating system, the hardware configuration is something which is selected by the provider, like maybe an organization, cloud provider, or stuff like that. That's basically what PaaS is, right? So yeah, this is Docker. Again, Docker, you install Docker, you get the interfaces to work with, right? I'll show you the demonstration. I'll go back to the system right now. I'm going back to the system right now. I'll show you the demonstration. There are a lot of commands which you can do. We can get Docker from internet. It's pretty easy to download that, right? And to run the containers, we have Docker images. So I'm going to download the Docker images. We'll show you. Can't go through all these operations, but we'll show you the basic way of deploying the applications using Docker, right? And then I'll show you a simple Docker file as well. So let me go back to my screen, my system screen, obviously, and I'll explain you these things over there, because I have a setup running. I have a simple machine running Docker right now. So I'll show you how exactly you can install Docker. By the way, you can install Docker on your local Windows machines also, for that matter of fact. Nowadays, they allows you this. So you should be able to see my screen, guys. I have one machine right now in front of me, which is currently running Docker. It should be visible to everyone, I think. Is it visible? Not visible? I'm not sure. Or is it blank? You can still see. No, it's visible. Okay. So this is just a simple Linux-based machine. It's an Ubuntu platform OS running Docker. So I've already installed Docker in. If I run a Docker command, you can see Docker is running. It's again CLI, guys. For those who are working on Windows, you can install Windows Desktop, Docker Desktop as well, which gives you a UI interface to run Docker commands. Docker info, if I show you, or let's say Docker version, you can see when you install the Docker version, so you can see Docker CLI, and server. Daemon is more like a server. It's basically a process which continuously runs in the background. So daemon, Docker, you understand, daemon is basically a process. So as I told you, the life cycle of a process, right? You have a code, it gets executed, gives you the output and the error, or the error, and then it gets terminated. That's how process runs. Daemon are the special type of process which always runs in the background, right? So like take an example, if your process is running, there's a request for that process, it comes in the foreground, serves the request, and then never terminates. That's what daemons are. So you can see Docker version shows you a client and the server, right? It's already installed on my setup. So you can see it has the client version, it has the server version also, right? So you got both these versions for us. This was I was talking about. So client is the CLI, okay? And the server which you're able to see is that daemon, right? So you basically have these things at the end of the day, right? So yeah, so if you want to use WSLs, we can use WSLs also. That's not a big problem. WSLs basically stands for Windows Subsystem for Linux, if I remember it correct, right? So currently you have this. I can run a command Docker images. You can't see any image on this system. So what is an image? Like take an example, if you want to install an operating system, we have to have an operating system image, ISO. Same way, if you want to run a container, we need to have what you call a container image. Threads are sub-processes. Okay, so process is the main thing. Threads are like you're having sub-processes, child processes. That's what thread is all about. Okay, so thread is, again, the processes, sub-processes, accessing the CPUs and the RAMs. That's what thread is, right? So coming back to the topic, I'll give you the Q&A, guys. Give me 5 minutes. Let me explain a basic Docker stuff right now. So we don't have any image locally available on my system, but I can go to dockerhub.com. So dockerhub.com is basically one of what you call a location, internet location. Technical term for this is known as container registry. This is where the images are stored. Okay, you can build your own container registry. You can use your own private registry as well. So within organizations, we can run our own container registry. This is one of the public registry which contains lots of images. Like take an example, I'm gonna go for HTTPD. This is web image. So you can click on HTTPD. Docker image is like ISO. It's basically a pre-built file which contains the instructions to run your process. Okay, it's like in simple terms, for installing an operating system, you need an ISO, correct? So same way, to run a container, we should have some instruction that what container is supposed to look like, which process it is supposed to run, stuff like that, right? Things like that. So all those instructions, all those things are technically stored into container image, Docker image, right? So Docker image is that file. So you can see this HTTPD is a Docker image. Okay, you can find image for anything. Like take an example, you're looking out for MySQLs, you have MariaDB, Persona, stuff like that, Jenkins, lots of images available for us, guys. There are methods given how to run those images also. You can see the quick reference for it, how to run it, stuff like that. All these things are. Okay, so again, this is just to give you the basic idea. So currently we have a lot of images available on the internet. I can download an image, Docker pull. Okay, docker.io is the URL. It's an alias for Docker Hub. And I want to download an HTTP image. We can simply run this pull command. This will go to the internet, will download that image onto your local system. Okay, so now if I run a Docker image, you can see I have an HTTP latest image available for us. Look at the size of it, 148 MB. So this image was created by the manufacturer or officials of Docker. You do have the options to create or build your own custom image. We can do that, right? And how to run a container? Currently, we don't have any container. You can see, right? We don't have any container to run it. I can run a container, Docker run -d -name is equal to cont1 -p8080:80 HTTPD:/latest. Now, this is an entire command to run a container. Okay, Docker run is the way to execute or run a container. -d is technically known as detached mode. So the process inside the container is generally like the way container images are created is to run the process in a foreground manner. Foreground manner in the sense they will be attached to this terminal. I won't get any access to work on this terminal. So we have -d option. Again, it's a way. It's a way to deploy a container. You're giving a name to the container, which is cont1 in simple terms. -p is port mapping. So you are basically kind of mapping the port of my physical host to the container port 80. So I know that this HTTPD image is going to listen on port 80. So that's what I mentioned. And then I'm kind of port forwarding that to port 80 of my system. So you put an enter. And now if you do a Docker PS, you can see I have my container running. And now if you're aware with the Linux machine, you can run a curl command, localhost :8080. You should be able to see it works. My website is up and running. My container is up and running. I can see the process running. Okay, so yeah, this is very fast track, frankly speaking. Usually whenever we deliver the course, we talk about all these things in complete detail, like how exactly images are created and stuff like that. But this is just to demonstrate it to you that how easy it is to run the containers. Hardly takes 1 minute or 1 second, I would say, to deploy the container and have your application spin up. And I can run the same command again with some other port number. Let's suppose 8081, the name of the container to be cont2. That's it. And now I would have 2 containers. So I can use the same container image to deploy multiple containers. Okay, and that's the functionality we have. We do have this option to use a single image to run more than 1 containers as well. And these containers, these processes are completely isolated from each other. They will never be interacting with each other. They will each have their own file system access. They will each have their own isolations, stuff like that. All right, guys. So this is, in simple terms, how easy it is to deploy the applications in the form of a container. We don't have to worry about installing any separate operating systems. We don't have to worry about installing other separate stuff. We only have to build our own container image using our own, like as of now, I'm using an official image from Docker, the HTTPD image from Docker, but you do have the options to build your own container image as well. Okay, you can build your own container image as well. Like within the production environments, we generally build our own container images. Okay, for our own customized applications, we can build them, we can work with them. Any questions as of now? We'll take 5 more minutes for any Q&A, and then we'll move ahead with the next topic of understanding how containerization comes into the picture. No. While installing, so Microsoft right now, it has its own subshell of LXCs, right? It basically has what you call the WSL stuff and like that. Okay, so WSL is the concept of running Linux-based applications on Windows machines, Windows 10s and 11s and stuff like that. So when you install Docker desktop, it basically uses those things. It never installs LXCs. Any other questions, guys? If I need a Docker container, says Windows, how to choose the RAM values? Docker container in the sense you're talking about running a Docker, using a Windows-based container, frankly speaking, that's what you're talking about. So obviously, if you go to Docker Hub and stuff like that, you will be able to find out the minimum requirement of CPUs and RAMs for a particular. Usually, they takes the CPUs and RAMs by default. You have the options to limit that also. That's an option which is available. If I need to consider volume and if I want to download a file which is saved in the container, I want to have it transfer from Docker container to, you can do that. You do have the options. So you have a Docker copy command in case you want to put some files from your local system to the container running inside the host. We can do that. There are options for it. Docker restart always is a bad idea. Depends. If your containers are going to crash, right? So Docker restart is a simple way of making sure that if by any chance your container gets stopped or failed because of any reason, it should automatically be restarted. It's not a bad idea. You can live with it. So take an example, if you're running a business logic applications and you don't want it to be failed for any reason, it should get restarted automatically in case of any failure, we run the Docker. Kubernetes we're going to discuss, don't worry about it. Images, container images are responsible to be run in the form of a containers, frankly speaking. So container images are technically supposed to run in the form of container. So container is what you call a runtime execution of a container image. Okay, the image built on the Windows can run on Linux. That's a very good question. Now, it depends upon the compatibility. Let me be very clear. You cannot run a Windows-based container on a Linux operating system. That's not yet possible. So if I have a container image which is created to run a Windows-based application, it can only run on a Windows machine. You cannot run it on Linux. The vice versa is correct because we have WSLs, which allows us to run Linux applications on Windows. So you can run a Linux-based container on a Windows machine. But if you have a Linux machine and you want to run Windows-based containers on top of it, it's not possible. Blah, blah, blah. How do we make STD Docker image to run custom application? Standard Docker image, you can build your own container image on top of it. Okay, so take an example. If there's a requirement to create, so if I go back in here, right, you will be able to see that I can find container images for operating systems also. Like take an example, if you go back to Ubuntu, you can find out Ubuntu images. Take an example, you want to look out for Red Hat image, you will be able to find UBIs for Red Hat, right? Take an example, you want to find out for CentOS, you'll be able to find out the images for CentOS also, right? So you do have the options to build our own custom images based upon the base operating system images. We can do that. I'll show you a Docker file, not to worry about it. I can see a lot of communications. Guys, this webinar, again, communications between containers happens via the IP addresses. If I have a local jar file on project, how to run this in Docker, you have to run it on site. So if you have a jar file, run it on OpenJDK container, right? I'll have 2 more minutes, whatever questions I can go with. So you have an OpenJDK container, you probably would have to copy that jar file within this container, right? So you have to build your own custom container image. That is something which you can do there. In Docker run command, you basically, so you do the -v option. The volume option is available for us. Take an example, if there is a folder in your machine /abc, copy that file inside that, use the -v option /abc, that will allow us to copy the file or mount that particular file system inside the box. We can do that. Docker Compose, Docker Swarm, both of them are outdated. There is no need to learn them. Learn Kubernetes, better solution. Okay, so Docker Swarm is not supported anymore, guys, frankly speaking. Okay, it was there in the market for a while, but it's not supported anymore, right? Officially, Docker has stopped supporting Docker Swarm, so we don't use. The better alternative for them is there in the market, which is Kubernetes. So we'll give some time on the Kubernetes architecture, what exactly it is. Okay, so Docker container is just the last solution for us. Docker image is basically a file which allows us to run the container. Docker file is, that's a very good question actually. So I'll give it the overview of this. To containerize any applications, guys, we have to create a Docker file. So let me show you a sample Docker file. I have it. I kept it just to show it to you. This is how a sample Docker file looks like. Okay, this is how a sample Docker file looks like, right? So you can see it contains a set of instructions and it contains the values for those instructions. So we have what you call a base image. Okay, we have what you call is a base image. I'm talking about a base CentOS image. On top of it, I can install my softwares, I can copy my data, and then I can run the process which we need to run in the desired container. Okay, so first of all, take an example. If you are an organization, a developer who needs to deploy their applications. So first thing first, you will create a Docker file like this. Within the Docker file, you will write the instructions of how the things are supposed to run, right? How, so take an example, if you want to run a jar or a jar file for within a container, you probably will be using an OpenJDK image. We'll use this add or copy command to copy the jar file inside that next container image of yours. And then within the entry point in the CMD, you will be executing the java-jar command or whatever command to get it run. So first thing first, you will have a Docker file, which will contains the set of instructions to create your own container image. All right. Second thing, the Docker file allows us to create a Docker image. Okay, so from the Docker file, you will run a simple command of Docker build to create our own custom Docker image. Then so from here to here, to reach from here to here, you will be using the Docker build command. So Docker file is simply a text file which contains the set of instructions. You will use a Docker build command to create a container image. Okay. And then you will use a Docker run command to get the Docker container running. Okay. This is what the hierarchy would be. Docker file will basically contains the set of instructions. You will use the build command to create a container image. You will use the run command, and then you will come back to the containers first. I'm not going to explain you Docker Compose or Docker Swarm. Reason being they are outdated. Okay, and for understanding more into it, let's talk more about what you call the Kubernetes concepts. Okay, so if you want to containerize any application, we have to create the Docker file from the scratch. Okay, now coming back to the history, 2013, right? 2013, when Docker became popular, when containerization became popular, frankly speaking, right? We have to discuss about Kubernetes, obviously, right? So I'm going to go back to the concept of containerization also, right? So eventually, in the year 2013, Docker became popular. Containerization became popular. Okay, so Docker, it allows us to run the containers on a single machine. So if I come back to this diagram right now, you can see this is what we have. So you got one machine with the hardware. On top of it, we have operating system plus kernel, obviously. On top of it, you install Docker and you're running containers with our applications. Okay, single machine running everything. All right, this was something which Docker offered in 2013. Cool. In the year 2014, Google, we all know what Google is. Google introduced Kubernetes. Let me give you the history of Kubernetes. Google started working on the concept of containerization from 2006 onwards. So from 2004, in fact, frankly speaking, from 2004 onwards, they started working on the concept of containerization. Once when Docker was nowhere in the picture. Okay, when Docker was nowhere in the picture, Google was already working on the concept of containerization. So in the year 2006, they created a project known as Borg. Later, they renamed this project to Omega. By the year 2010, Google, being Google, was already running their solutions on containers. So like in 2010, if you open Gmail or Google Maps or Orkut at that particular time, right, or iGoogles and stuff like that, in 2010, if you access any of those applications, you are already running containers in Google, right? Docker came into the market in 2013. The concept of containerization became popular in 2013. But Google was already running their own products, their own solutions on the basis of containerizations as early as 2010. Again, a good lesson on history, right? So like in 2010, Docker was not there, right? So they were already running their solutions on containerization, right? And when Docker became popular in 2013, when Docker became popular, what Google did, they donated their entire work to a project known as CNCF. They donated their entire project to CNCF, this entire project, their entire 10 years of labors, while keeping it secret from everyone else. They basically donated this entire project to CNCF, and CNCF renamed that project as Kubernetes. Okay, so what exactly Kubernetes is, if someone asks you, right? Kubernetes in technical term is an orchestration system. That's what Docker Swarm was, right? Kubernetes is an orchestration system. Now, Docker allows us to run containers on a single machine. Okay, Docker allows us to run the containers on a single machine. If we want to run containers on more than one machine, simultaneously with proper reliability, accessibility, monitoring, stuff like that, we need the orchestration system. Let's say, take an example, if you're running like this, containers like this on a single machine, you're running a Docker, and on top of the Docker, you're running containers. What if this machine crashes? All the containers, all the applications running on the machine also crash. You don't have any reliability. So at the end of the day, Kubernetes is basically the orchestration system, a solution which is a combination of more than one systems orchestrated together to run container in a production environment. That's what Kubernetes is. And it's a brainchild of Google. Okay, it's a brainchild of Google. Cool. So you can see there are a lot of pointers for it. If there are multiple containers which are going to run on the machines, how they're supposed to be coordinated, what CPU RAMs to be allocated to them, how they're supposed to be scheduled. Take an example, one required more CPU RAM, which container to get crashed upon and stuff like that. If in case there's a requirement for upgrading the applications without any interruptions, how can we do that? To monitor the applications, and if by any chance something goes down, how to upgrade or restart it. All these things are basically the requirement of introducing of an orchestration system. Okay, so if you talk about the life cycle of an application inside a container ecosystem, guys, okay, the first week would be on any container engine. So Docker was introduced in 2013. From Docker, from 2013 to 2024, there are a lot of others. So Docker was a container. Docker still is a container engine, right? It's a C container engine. So from 2013 till 2024, there are a lot of container engines which were introduced. Like Docker, you talk about RKT, you talk about CRI-O, you talk about Containerd, you talk about Podman. All these are the alternatives of Docker which are there in the market now. In 2013, there were no other alternatives. Okay, it was only Docker. But from 2013 till 2024, the time which we are sitting right now, is when there are a lot of other open source projects which came into the market, which understands the, I would say, the limitations or drawbacks of Docker also, because Docker, again, was not that mature at that particular time, right? So all these other container engines which came into the market are, somewhat more mature, somewhat more flexible with respect to providing the functionalities and stuff like that. So the life cycle of container, the reason why I'm showing you this particular slide is, take an example. If you need your application to be containerized, initially you will be using any sort of container engines like Docker or CRI-Os or Containerd or Podman. And once that application is tested properly, you will be running it on a container orchestration solutions like Kubernetes. So there is a question that, to run Kubernetes, do we require Docker? Yes. The answer to the question would be, to run Kubernetes, we required container engine. The container engine could be Docker, could be CRI-O, could be Containerd, could be Podman, could be RKTs. I cannot go into that detail, man. The node selector, taint tolerations, affinities, anti-affinities, these are the scheduling mechanisms within Kubernetes. We are not here for understanding the entire Kubernetes lecture. These, I can see there's a concept of K8 Helm charts also. That's a method of deploying. We have limited time. We only have hardly 10 more minutes for us to understand Kubernetes as well, right? So these topics, again, we basically have official contents for delivering all these things, right? Maybe you can put these queries. I hope Ria is also considering all these things. These are the topics which I generally cover up in the training, not in the webinar, frankly speaking. But yeah, I will make a note of this. Maybe I can give you some explanation on this written later on. Maybe you can share your email ID and we can share it to you. Docker is a container engine. Podman is another container engine. Docker was created by Docker. Podman is created by Red Hat. Docker is supposed to run from root. Podman does not run via root, right? It does not require root access by default. That's major difference we have. Okay, and then there are a lot of other technical things. But frankly speaking, basic difference, Docker is the daemon stuff which runs via root. Podman does not require the root access. right? So there was a lot of other container orchestration tools which we have. Docker Swarm is removed. It's not supported anymore. In the year 2021, they stopped supporting Docker Swarm. Same for Apache Mesos also. So if you talk about an orchestration tool on containers right now, the only options which is available for us is to use Kubernetes. Now you can use a managed version of Kubernetes or you can use an unmanaged version of Kubernetes. It's your choice. But Kubernetes is the only solution which we have in the market when it comes to container orchestration. You can't find any other tool, right? You say AKS, EKS, GKEs, RKEs, stuff like that, OpenShift, whatever. All these things are derived from native Kubernetes solution. Okay, so you need Kubernetes to work on, like if you're running a production grade application or production grade container ecosystem, you will be looking out for a way to, understand how Kubernetes runs in simple terms. All right. There are a lot of things, guys. As I told you, this is just a small introduction, right? All the questions which I'm able to see, I can see there are some people who are aware with some basic technologies or terminologies within Kubernetes also. For some of you, it's completely new. So this is just to give you the basic understanding. So the idea for this webinar was to give you the understanding on the 4 terms. What exactly is the difference between container, Docker, and Kubernetes? Because people generally get confused when you talk about all these 3 things in one sentence, right? So now we have an understanding. Container is an end result. It's the end product. It's the way to deploy your applications in an isolated manner. To run containers, we can have Docker or any other container engines for that matter of fact. And then in case we are looking out for a way to deploy the containers in the production ecosystem with all the reliabilities, monitoring functionalities in there, we probably would need a container engine or a container orchestration tools like Kubernetes. All right, we can set up Kubernetes very simply, guys. It's pretty simple to set up a Kubernetes cluster, and this is how a very simple Kubernetes cluster would look like to you. So you will have, like, this is a very generic one, like the 3, as you can see over here. How reliable is Kubernetes with cloud? Everyone is running Kubernetes on clouds. Like you talk about EKS, RK, like EKS, AKS, or GKE. These are managed Kubernetes versions running on cloud platforms. Like EKS runs on AWS, AKS runs on Azure, GKE runs on Google. Reliable in the sense, if you're using a managed Kubernetes cluster from any of these cloud providers, I would say it's 100% reliable because you don't have to worry about anything apart from just deploying your applications on top of it. Everything else is managed by the cloud providers. And frankly speaking, clouds are very stable as of now, right? The AWS, EKS, or GKS, or GKEs are very stable, right? So running a very simple cloud, so I'm going to explain this diagram. This is a very simple diagram to understand, guys. This is, I would say, a very simple picture of how Kubernetes cluster runs. So we actually runs Kubernetes cluster in a very simple, like you can have machines. 3 machines are the bare minimum machines. So 2 machines can be the bare minimum machines. You can also run a single Minikube setup. That's altogether is a different thing, just for POC purposes. This is a very simple setup. I will share these slides. Slides, recording, everything will be shared, guys. Not to worry about it. So we have one machine, which is technically known as master machine. Okay. So one machine is the master machine. This is where I would say the control plane of Kubernetes runs. The brain of Kubernetes runs. All the components, all the services responsible for making sure that your Kubernetes cluster and the application on top of the Kubernetes cluster is running perfectly fine. It is something which is managed on the control plane, the master machine. Like you can see over here in this slide, we have API server, scheduler, controller manager, and etcds. These are 4 major services responsible to make sure that your Kubernetes cluster runs as expected. The applications on top of the Kubernetes cluster runs as expected, right? So master machine is technically the machine where the control plane, the brain of Kubernetes runs. These nodes are technically known as worker nodes. Okay, these nodes are known as worker nodes. This is where your applications would run. Okay, so take an example. If you're running an applications, they will run in the form of a container on these boxes. And you can see the ones which are basically having a pink background are components of Kubernetes, right? Like on the worker nodes also, you have kubelets and kubeproxies, components responsible for making sure that your applications runs. Then network connectivities are provided. So if I have to give you one-liner explanations of all these things, API server is the component which allows the communications within Kubernetes cluster. All these components, if they want to communicate with each other, they basically, they basically will interact with the API server. Scheduler is the component which decide which worker node to choose for deploying your application. Controller manager is the component responsible for controlling everything. So if their application is running, by chance, if the application goes down, it needs to be restarted. The IP address allocations to that thing, the host allocations and stuff like that. So controller manager is that component which makes sure that your application runs as desired. etcd is technically what you call the I would say the data store, which contains the metadata information of your Kubernetes cluster. So if your application is running, you talk about what's the host name given to that application, the IP address, which worker node it goes, which version of the application which is running, everything is getting stored on etcd. So metadata of your application is technically stored on etcd. Kubelet is the client agent, I would say, component responsible for communicating with the control plane of Kubernetes to get the instructions from it and then talk to the container engines like Docker or CRI-O or Containerd to create the applications in the form of container. Kubeproxy is the component responsible for communication for your application. If the application is supposed to communicate internally, externally, whatever, we basically have kubeproxy. Can we deploy Docker containers and run in Windows servers? Docker you can run. You can't run Kubernetes on Windows. The control plane of Kubernetes needs to run on a Linux machine. The worker nodes, now we have the solutions to run worker nodes on Windows. Like earlier, we don't have that option. Now we have it.
This is an architecture. We also have, talking on this, just give me a sec. Right. Yeah.
The deployments, like there is a lot of ways to deploy the applications on Kubernetes, but the more standard way is to deploy it via deployments. So deployment is a technical resource. It's basically an object resource within Kubernetes, which allows us to deploy the applications. It simply creates replica sets and pods in general. And the benefit of deployment is that you technically can upgrades or downgrade your applications whenever you want. So the technical way of deploying your applications, like in Docker, we run the Docker run command. In case of Kubernetes, we basically have to what you call create the deployments using the YAML line formatters, right? So any object which you want to create within Kubernetes, I'll show it to you on the screen right now. We'll deploy an applications and we'll also see how can we upgrade and downgrade an applications using these strategies which are available for us, right? And that's something which I'm going to show you. Like we don't deploy the containers right away directly within Kubernetes. We do have the options to deploy it via the pods. That's technically what we do within Kubernetes, right? So let me show you how easily it is to deploy an application on Kubernetes as well. For that matter of fact, you should have a Kubernetes cluster. Frankly speaking, if you don't have a Kubernetes cluster, you can't do the work. Setting up a Kubernetes cluster, again, is not a huge thing. It's pretty simple. I already have a Kubernetes cluster running for me. You can see we have one masters and multiple workers. Okay, so you got the masters and the workers to operate with, to work with. You can simply run or you can simply create a deploy.yaml file. So, and I don't have to go anywhere else. I can simply go to Kubernetes documentations, kubernetes.io. This is the Kubernetes documentations. We can directly go there, search out for deployment. Frankly speaking, you can copy paste the entire YAML from here itself. You don't have to worry about doing anything else, right? This is simple deployment.yaml for us to work with. Okay, so this is a way of deploying the applications. I'm going to create 3 replicas for us. We'll have this Nginx image for us to work with. I'll just change the name of this container so that right? And you can create. So like when you talk about going through the lectures, we generally create this thing. You can deploy, sorry, kubectl create -f deploy.yml, and this will basically deploy the applications for us. So you can simply do a kubectl get deploy, right? It will basically take some time to download the images, but my applications will eventually be deployed. We generally copy paste. So like when we go through the lectures, the first thing which we have to understand is like, obviously, understand how the container images are built, but you have these deployment options. And then if you open up the cheat sheet, there are a lot of options to upgrade the applications as well, right? So they might have removed this. Wait, they have removed it. Okay, so these are set image options and stuff like that, right? Where you can simply set the image for a deployment to which particular image you want to upgrade to. You can do a rollout, you can do an undo, you can do a stuff like that. So there are a lot of operations which you can perform with respect to your deployments, the application deployments, obviously, right? Pod, in simple terms, is a container. Pod is equal to container, I would say, just to understand on a very layman term, but technically it's a logical collection of one or more containers which can be bind together, right? So you can deploy your applications. The moment your deployments are done, you can see deploy, and you can do a kubectl get pods. I'll show you the pods which are running. That's what we have eventually. Kubernetes is an orchestration tool. It allows us to do a lot of different things, guys. Like take an example, if I do a command right now, kubectl describe deploy, it's a huge name, Nginx deployment. If you do this, you can see the image which we are using is Nginx :1.4.2, right? I can simply run this command, set deployment. The name of the deployment is Nginx deployment. And then I can change the name of my image of my container. So container1 image, I just want to change it to, take an example, Nginx :latest. And if I do this, if I do a describe command again, it shows you image is this, kubectl get pods -w. You can see the latest version is automatically getting upgraded. So you have very simple options to upgrade or downgrade the applications via Kubernetes. You have the options to do the monitorings via the Kubernetes. You can do a lot of other functionalities using Kubernetes in general, which by default is not available within the Docker ecosystem. So working with Kubernetes gives you the functionality to understand how to run the applications in the production infrastructures, accessing them, working with them, doing the operations on top of them and stuff like that. So Kubernetes is an orchestration tool which you can run in the productions to run a proper, complete container ecosystem with high availabilities, reliabilities, monitoring and stuff like that, backups and log monitorings, do a lot of things, right? Docker is a standalone container engine, which allows us to run containers on a single machine. And containers, in simple terms, is a way to deploy the applications altogether. Right, guys? I know this is a fast-paced type of thing, but as I told you, the objective for this was to make you understand the difference between all these three things. We haven't gone into I would say I haven't taken the deep dive into it, and the reason for that is because we have a limited time frame to cover up all these things. Right, guys? Any questions on this? I'll take final Q&A for any of these things. Slide and recording, as Ria has already mentioned, will be shared to you guys. That is something which you don't have to worry about, right? Any questions? Any final things? Any final stuff for you guys to ask? Yes, we basically don't have to worry about running any commands on Docker. Everything will be managed using Kubernetes. And that's what Kubernetes offers to us. You don't have to go to the underlying infrastructure or underlying setups of how Kubernetes is running the setup. You just have to run Kubernetes commands. You have to manage everything via Kubernetes, and it will perform the task for you. Any other things, guys? So first, you have to install a container engine, not specifically Docker. You have to install Docker. Okay, so you have to install a container engine first, and then on top of it, you have to install Kubernetes. So general architecture is first you will have container engine installed like Docker or CRI-O or Containerd or whatever. Once you have installed the container engine, on top of it, we can run Kubernetes. Docker Compose is a file to deploy application on a Docker Swarm setup. Okay, so take an example. If it's like a deployment file which I have just created, Docker Compose, again, as I told you, it's not being used anymore because Docker Swarm has been retired by Docker organization, right? But Docker Compose was a file to deploy an application on a Docker Swarm setup. So take an example, if you have to deploy an application to run 3 containers simultaneously on 3 different servers, we basically create the Docker Compose. Depend upon the choices, your requirement. If you want to go more native, use Containerd. If you are somewhat familiar with Docker and you want to use the functionalities like that, use Containerd, CRI-O. Okay, so it depends from choices to choices. Majority of the time, you will see Containerd in the operating system. We have 3 server IPs and we need to deploy an application, all 3. Obviously, you have to add them as an agent first. First of all, you have to create a Kubernetes cluster. In the Kubernetes cluster, you will create 1 master on those servers and 2 worker nodes, and then eventually you'll deploy the applications on top of it using Kubernetes. Okay. The concept is you have to deploy the applications in the form of containers. If you don't have the applications running in the forms of containers, you don't require Kubernetes. But if in case you want to deploy that application in the form of containers, you probably would first set up the Kubernetes cluster, and then you can deploy the applications. The answer to the question, can we deploy custom image from Dockerfile? Yes, perfect. That's what we do in CI/CD, guys. That is what we do in CI/CD, where we have a custom Docker file created and stored on GitHub. Eventually use the CI/CD tools like GitLab or the Jenkins to extract or build a container image through it and then deploy it on a Kubernetes cluster. Podman, Containerd, these 2 are different types of container engines, right? Frankly speaking, Containerd is something which is owned by an open source organization, CNCF more specifically. Podman is more into Red Hat. So it's more like a proprietary solution of Red Hat. Again, the functionalities are altogether the same. The only thing which varies is their interfaces and stuff. You run the Kubernetes command on anywhere, in fact. For that matter of fact, you just have to install the CLI of Kubernetes, specifically known as kubectl. So you have to install the kubectl. You can install kubectl on your personal laptop. You just need to get authenticated with a Kubernetes cluster, and then you can run the command anywhere. The difference between K and OpenShift, guys, OpenShift is based upon Kubernetes, frankly speaking. Kubernetes is an open source of orchestration tool, and OpenShift is a wrapper on top of Kubernetes, which gives good user interface to the end users for deploying their application. So like for Kubernetes, we don't have any good user interface like a dashboard or stuff like that, where you can do the deployments via the user interfaces. OpenShift is just a wrapper created by Red Hat on top of Kubernetes platform. There is no other different container orchestration tool we have apart from Kubernetes. The only thing you have in the market is OpenShift. OpenShift is based upon Kubernetes. There is no other alternative container orchestration tool we have. There are versions of Kubernetes which runs in the market. Like, as I told you, if you want to go onto cloud-based, you can use AKS, EKS, or GKEs. If you're working on the data centers, we can deploy OpenShift. We can deploy RKE, Rancher, Kubernetes engine, and stuff like that. Okay. Kubernetes is the sole, it's kind of a monopoly we have in the market with respect to container orchestrations nowadays, guys. Any other questions? Command structure, like in the sense, how do you run the Kubernetes command? It's pretty easy. It's like you have this kubectl command. This is the client. So kubectl, you have verb, So verb is like what you want to do with kubectl. So you can do a create command, you can do a delete command, you can do describe command. There are a lot of things, right? So you do a kubectl, put an enter. All these are the verbs, right? So what verbs you have, you can basically use any of these verbs. And then you have resource types. So kubectl, like if you say get notes, so get becomes the verb, and notes is the resource type. So you can see it gives you the output. How many resource types you have? Was that API resources, right? So all these are the different resources you have. So you can basically run the command kubectl verb and the resource, and then you have resource name in case you want to give it. So that's basically how you can run a simple command of Kubernetes. Now, guys, any final questions? If not, thanks a lot for joining in this session. I hope you got substantial output from this. I know it's kind of a fast track thing, but as I told you, the objective for this is not to train you on Kubernetes. Frankly speaking, it was, or Docker for that matter of fact, it was more with respect to giving you the idea, understanding the difference between the terminologies which we use on day-to-day basis on container ecosystems, guys. With that note, I'm done. As I told you earlier, you will have the recordings, you will have the slide stack with you, right? You can get a lot of documentations. I'm basically have a lot of documentations created, but it's more with respect to, I have to have the IDs to get it shared to you guys, right? So yeah, you can use this and maybe reach out to our team, the R&D team. They will let you know what exactly or how exactly you can get more informations and documentations on top of it. Right, guys? Thanks a lot. You guys have a nice day. Cheers.